Hello, my name is Ricardo. I will make a presentation on behalf of Multimedia Brazil. I'm part of the team, but we have some sub-teams that were focused on different tasks. I might not be able to answer all your questions because I did not actively participate on these tasks, but the authors would be thankful, would be great if you contact them, we will shortly answer you. Their email will be available at working notes, and they will be present on the retreat session on Friday. Online, not here. Well, these works relies heavily on neural networks to end-to-end learning. As presented before, we have two subtasks. For the DIRSM subtask, they exploited convolutional networks and relation networks mainly. These are the official results for the runs at this subtask. The best AP result is achieved by run 3, and run 4 obtained the best map at 100 to 50 for 80 cutoffs. And each run is configured as follows. Run 1 is a fine-tuned Google net. It's pre-trained at ImageNet and replaced the last layers with one containing only 2 neurons where they classify between flooded or not flooded. One observation is that all images were cropped of 224 by 224 pixels from the center. So it's the accepted input for GoogleNet. This is only a visual run. Run 2 is an only textual run, consists of converting tags and images descriptions into a set of words. These words are mapped into vectors with a conversion table learned by a network. This is a relation network capable of processing pairs of objects from a collection, with the intent to discover relations between them. The motivation to use this method is on the hypothesis that the problem is significantly simplified when, instead of trying to understand the text, we understand the co-occurrence of words. Run 3 is the first multimodal approach and the best AP result. The textual is the same as run 2, and visual is a ResNet 18, but changing their last folders, respectively, by a 256 ReLUs and 512 ReLUs. Their outputs are concatenated and go through a fully connected 768 ReLUs, 512 plus a 256, followed by a dropout classification folder. This is an end-to-end approach. Run 4 is the same idea as run 1, the GoogleNet, but they train 5 independent Google Nets into a process similar to a 5-fold cross-validation. In the end, is computed average output and used as a rank. Run 5. For each test set metadata, we estimated its probability of being a flood, using some ranking functions and merge them into one unified rank. Then evaluating it with a ranking quality statistic and DCG, normalized discounted cumulative gain, where basically with more floods on the top of the ranking, higher the probability. Now for the second task, the FDSI, which refers to segmenting flooded areas in satellite images. It exploited mainly dilated convolutional networks. We can now see here, by roughly analyzing it, that run 3 obtained the best results in both, and followed closely by run 5. Run 1, it's basically a neural network composed of 6 dilated convolutional in series, training with the entire development set, in patches of 25 per 25 pixels with a 10 pixels of intersection. Run 2 is the same exactly as run 1, just switching to a 50 per 50 patches, 50 per 50 pixels for patches, on the idea that more context might be more useful for the neural network. On run 3, the best run combined different architectures. The ones from run 1, 2, and 5, and 2 new ones based on deconvolution and dilated convolution, but with a pooling. All probability outputs for each location were concatenated, and a linear SVM is applied over this. Each location is treated in a jointed manner during training, but that means that the SVM is trained for all locations. But for testing, each location is treated independently. Run 4 is pretty much like run 3, but switching the linear SVM by a majority voting approach, and each location is treated independently. Run 5 is basically run 1, the dilated CNN, but instead of 6 in series, there were 1 for each type of location, specializing each one on a specific location. Then, for a new location, all outputs are concatenated and processed by a linear SVM. Only one SVM is trained for new and seen locations. Here are the the active researchers on this task, their locations on the map, and thank you for your attention. That's all. I'm open for questions, and probably they are watching that right now.